Welcome to day 2 of 3D graphing. Yesterday we just learned how to graph points, basically. We talked a little bit about the planes, but today, you know what that is. We're going to graph spheres. If you ever doubted your drawing skills, today's the day to. It's bad. I'm going to do my best, but when you see that 16 right there, what do you think the radius is? It would be a radius of 4. And so my favorite way to do this is all centered at the 0, because we would just have a standard x squared, y squared, z squared. So we're going to have the center at 0, center of our sphere, and then in every single direction, up, down, left, right, all the directions, we're going to go to the 4. To the 4. 1, back 4, forward 4, to the side 4. Back to the other side 4. So actually right now what we have, if you connect those points, use your imagination a little bit, that should actually be a circle that's laying on the ground. I like to think of it as the equator of our sphere. So that's an actual circle, but it's laying on the ground, so it doesn't look very circular. But now we still haven't done our upsy downsy. Let me erase this just so it kind of looks like that equator goes behind that z-axis. So now we need to go up and down by 4 as well. So from the center I'm going to count what I would say is 1, 2, 3, 4. And down 1, 2, 3, 4. Again, I'm just kind of making that up. So this would be our North Pole and our South Pole. And so let's try to make a convincing looking Earth out of that. So if that's our North Pole and this is our South Pole, oh dear. So that's supposed to look like a sphere. I don't know. It'll probably just get worse if I try to draw latitude, longitude lines, but I think that's my best attempt for our first sphere. That's a sphere with radius 4. You can see on the at least on the x, y plane, that would definitely have that radius of 4 going on. Oops, that went a little far. And then our radius of 4 up and down. So that's going to be my version of a 3D sphere centered at 0, 0, 0. Let's try another one. So this one has a different center. The center is going to be at the ordered triple 2, negative 3, 1. If you're with me, 2, negative 3, 1. Let's find that center point. So 2 is my x value, so I'm going to come forward 2. Negative 3 on y means to the left. And then I want to come 1 unit up. And so really I'm thinking what's 1 unit on the z-axis, and that's how far I'm going to come up. And so it's kind of sitting over there. What would that be? Octant 4. We've got the center of our sphere sitting up there in octant 4. Okay, let me try to draw it now. So what's our radius? Radius is 2. And so I think I'm going to start with my equator. So from the center point, I'm going to pretend I'm counting over 2, and to the left 2, and backwards 2. And see how I'm going at a diagonal though, because forward and backward is at a diagonal, right? Forward 2. Maybe I actually want to put those in, because this doesn't look kind of like a little helicopter sitting suspended up on that center point, right? Well, that's my equator. And now I have to make it convincing to look like it's going to go up and down. I think I'm going to get the helicopter part out of there. So that was my radius of 2 I was trying to show. I don't know, maybe it looks better with that in there. Oops. So from that center point now, I need to go up 2 and down 2. So again, I'm thinking like counting like z-wise. I want to go up this far and down that far. So from the center point, I'm going to go up to the North Pole and down 1, 2 down to the South Pole. And so I've got, that's supposed to be my sphere that has its center kind of raised up in the air over there, right, out in the hallway. And we've got our equator that goes around. And then our up and down for our north and south pole. That's the best I can do. Maybe your pictures are beautifuler than mine. Shade them in or something. That would be sweet. Okay, now if you think about this sphere, I feel like the entire sphere is not going to be all in octant 4. Okay, so this is outside my door, right? If we're thinking in terms of my room, Mrs. Brock's room, and all of that, since it has this -3 coordinate, that means it's going outside my door, right? But I have a feeling that's actually going to have to dip into the basement a little bit. And the reason I think that is because the center is only let's say 1 foot high. So if your center is up at 1, let's say this is our y-axis, and if our radius is 2, can you see that sphere would actually go down into the basement a little bit? It's hard to see because, first of all, my drawing, and second of all, because it's just hard to draw. But that's what this is talking about when it asks, where does the sphere intersect the xy plane? Remember that the xy plane is what I called the floor, if you're visualizing it like that, because the xy plane, remember when we colored it? The xy plane is all the tile floor, right? And so that sphere is actually going to sink into the ground a little bit. And we want to find out, would we have to cut a square hole to let it go down? Would we cut a circle hole? How would we get that sphere to let its south pole go down underground? So here's how it works. What do we know about the xy plane? We talked about this yesterday. The xy plane has no height because it's on the floor. So it's got an x value, it's got a y value, but the z value is always 0. So let's think about our sphere. We're going to take this equation from way up here and just think, well, what about the points on the sphere where z is 0? That'll tell us everything we ever wanted to know about the sphere and its relationship to the floor, to the ground. So watch carefully, we're going to put a 0 in for the z value. There's actually lots of different points on the sphere that have z values of 0. And this is just going to sort of describe those. I'm going to do a little work with this though. This part right here. The 0 minus 1 is -1, -1 squared is 1. So we actually just have a 1 right there. If we subtract 1 and move that to the other side, hopefully you're with me on the algebra here. If we subtract that over to the other side, we're going to keep these as is. But if we take this chunk, this 1, and we subtract it to the other side, we wind up with a 3 over here. And I hope that you recognize this equation. That's the equation of what? It's the equation of a circle. And so remember when I was saying we need to let this sphere down into the basement a little bit because its radius is a little large if it's only going to be up at 1, right? So if it's supposed to go down 2, it's going to sink down into the basement. Well, how are you going to allow it into the basement? You're going to cut a hole in the floor. Can you just imagine that sphere kind of just resting in the hole, all nice and cozy like that? And then you're going to, if you were downstairs, you'd see just like from the ceiling, you'd see just a little sphere butt kind of hanging down, right? Yes. You know what I'm talking about. Anyway, if I were going to graph, we call this the XY trace. Did you see that word there? The XY trace. Because if we traced out the part of the sphere, maybe that's not the best color. If we traced out the part of the sphere that hits the ground, it's going to have a slightly smaller radius in there, right? I shouldn't cover up that equator because it's underneath the equator. What is the radius of that trace? Well, whatever the square root of 3 is. It's like a radius of only 1.7 down below the equator, right? That circle. I don't know how well you can picture that, but I have an idea. I have an idea that we're going to try to build one of these. But for now, we're just going to have to do our best and try to draw 3D on a flat piece of paper. Thanks for watching.